plus 2. Okay, good. 2c, you're right. Thank you. Way to catch me. Plus 2c, good. So now over here, we've got some x squareds, and we've got some x's, and we've got some constants. So first with our x squareds, how many x squareds do we have on the left-hand side?
0.
0. No x squareds is going to be equal to our ax squared plus our bx squared. How many x's do we have on the left side? 1x is going to be equal to what on the right-hand side? 2ax plus 3bx plus cx. Good. So let's cross these ones off as we're doing them. 2x, 3bx. And now, what is our constants on the left side? Negative 3 is going to be equal to a plus 2b plus 2c. Good. So we have 3 equations and we have 3 unknowns, a, b, and c. Can we solve this?
Yes.
Good. Yes, we can. So let's take the first one. We can factor out an x squared off of every side, and then we're just left with 0 equals a plus b. So let's put, let's do b in terms of a. b is equal to what? Negative a. Good. So, and let's plug that into this third equation right here. So we've got a plus 2b plus 2c, but we know our b's are negative a. Oh, actually, you know what? Sorry, I'm going to switch that. We're going to solve in terms of a. What was a equal to? Negative b. Same thing. Good. They're just negative of each other. Okay, so a plus 2b plus 2c into this second equation. Now let's do the third. Okay, let's put it into the second equation. That one's going to be easier. Okay, so we've got 1 is equal to 2a, but we know HA is negative b plus 3b plus c. So we've got negative 2b and 3b. What does that make it? 1 equals to b plus c. So that's a good equation we're going to use into this third one. We could factor this third one into a plus 2 times b plus c. Does everyone see that? Just factor it out at 2. And we know b plus c is equal to 1. So negative 3 is equal to a plus 2 times 1. So what is a equal to? Negative 5. Good. Now we have a. What is b? 5. Good. How did you get that? Into the first equation. A equals negative b. So whatever a was, b is just the opposite of negative of it. And then what is c? Negative 4. Good job. Okay, so now over here on the side, what's going to be our partial fractions? We've got a over x plus 2. What was a? Negative 5 over x plus 2. And then b was 5 over x plus 1. And c is negative 4 over x plus 1 squared. And there we have our answer. How can we check our work? Yep. Add these back together and see if we get our original equation.
I don't like it.
So on the bottom, when you put negative 3 equals a plus 2 times b plus c, I don't see where that came from.
I just factored out a 2 from b, 2b, and 2c. I factored out a 2, and that still remains b plus c.
Okay.
And then we had this equation, b plus c is going to equal to 1, so we can plug in a 1 right over there.
So you don't have to set answer equal to x minus 3 over x plus 2?
Yeah, we should. We should. Still, there still should be this big equal sign in this right here. I just kind of ran out of room.
Okay.
We'll have a little bit more room on the next one. Good on that one? So that was repeated linear factors. Now turn over your pages. Situation C are non-repeated quadratic factors. So step number 1 is proper fractions. Is this a proper fraction?
Yes.
Why?
Degree is less than bigger.
Good. The degree of the numerator is less than the degree of the denominator. Now, number 2, factors. Is this a factor? No. Who's going to factor this for me?
It's like x plus 1.
2x plus 4, we'll leave that on the top. But the denominator can be factored to
X plus 1 times x squared plus x, I don't know.
pretty close.
So just do x squared and then x minus 1.
No, close, you're thinking the right lines though.
It's x minus 1 in parentheses.
Okay, there we go, that's where we'll start. X minus 1 in parentheses, because we've got a cubic and there's a negative sign here, so we can factor that.
Maybe x
X
squared
minus 1 and then what? X squared, good.
plus x
Plus x plus 1. Good. So what kind of factors do we have in the denominator here? 1 linear and 1 quadratic. Good.
Can you factor the numerator?
You could. Is that going to help us cancel anything on the bottom? No, it's not. So we could actually just leave it as it is. If it does factor something out and you can cancel a common factor, then yes, go ahead and do it. Okay, so what are we going to have over here? First our a over what? Good. X minus 1. Good job. And then what are we going to have that it's added to? What was step number 4? I know it's behind the screen now.
Dx plus c.
Good. Dx plus c over x squared plus x plus 1. Okay, good. So we've got, this is going to be for our linear term, and this one is for our quadratic. Now let's set them, get them equal to each other, and put we just want 2x plus 4 on this side. So what are we going to have here? A has to be multiplied by x squared plus x plus 1. Good. And then we've got bx plus c. Now that's one whole term. What do we have to apply? Multiply it by? Good. X minus 1. Did you guys use the word FOIL? Good. So we're going to have to do that. 2x plus 4 still. Ax squared plus ax plus a. And then we're going to have to FOIL this out. What do we have first? Bx squared minus bx plus cx minus c. Good. Everyone follow that? All right, we've got them all set. Now let's gather our like coefficients, our x squareds, our x's, and then our constants. So for x squareds, do we have any on the left-hand side? No. 0 is going to be equal to ax squared plus bx. So what do you know from the time before?
It's gonna be
A equals negative b again. Good. Now with our x's, what do we have on the left-hand side? 2x ax minus bx plus cx. Good. And then with our constants, what's on the left? Minus c. Good. Yeah, there's no b's on that one. So this is going to be handy too. Let's use that third equation and solve for a again. Or actually, no, let's solve for... I always choose funny ones. First one, b is equal to negative a, or a is equal to negative b. And then what is C equal to here? A minus 4, yeah, negative 4 plus A. Okay, so we've got these two equations and they're both written in terms of A, so let's just plug it into this second one. Sorry, I'm gonna put a tab right here. So we've got 2 is equal to A, and then minus what's B? Negative A, and what's C? A minus 4, good. So now everything's in terms of A, let's combine them together. Sorry, this should not be a negative. 2 is equal to 3A minus 4. Now where do I go from here? Add 4 to each side. So 6 is equal to 3A. What is A equal to? Good. What is B equal to? Negative 2. What's C equal to? Yep, you're right. Good. C equals negative 2. Okay, so there we've got our constant, so let's put it equal to our whole expression, 2x plus 4 over x cubed minus 1, or we could have factored that. And then what was A? 2 over x minus 1 plus B is negative 2x plus minus 2 all over x squared plus x plus 1. There's our final answer.
So that's all.
After we check our work, you have to just add these two partial fractions back together, you should get the original equation. Okay, for this last one we've got repeated quadratic factors. Once you go ahead and work on this one on your own, and then we'll go through it together. Okay, he has a good question here. Say it again for me. Okay, we've got the x cubed on the top right, so the degree of that is 3. But we've got x squared on the bottom, but we also have it squared, so by the power rule, we've got 2 times 2 is 4. So we do have a proper fraction here. We've got degree 4 on the bottom and degree 3 on the top. Okay, so everyone quietly take some time, see if you can work this out, and then we'll all come back together. I'll get what you guys can think.
All right, good work.
No, I'm so.
No, you can't.
Yeah, there's already 2 quadratics that are irreducible already.
Okay, so we just do
Open up that hint on the board pretty soon. So we've got 2 So we're just going to leave it as